So with some of the questions that we're going to be asked when it comes to exponential growth, this question is very similar to what we're dealing with right now in the United States and the world. We're not necessarily just dealing with a bacteria, but in this problem, it's the same type of growth. A type of bacteria has a highly exponential growth rate at 80% every 1 hour or every hour. So in this question, in terms of time, what is time being measured in? Very good. Hours. And what's our rate of growth? It's 0.8. Okay, so I just want to make sure. If there are 10 bacteria, determine how many there will be in 5 hours, 1 day, and 1 week. So we need to know all of our variables in this problem, which our problem is okay. Now, what was our principal amount or our starting amount for the bacteria? I want to see some more responses because I want to see that you guys are understanding this. Very good. We have 10. Like we said before, our rate is at 80%. So it's 0.8. Now our t, we're going to have different times. So we're going to have t equals 5, because that's 5 hours. Okay. For 1 day, what are we going to put for 1 day? I want to see what are you guys thinking. Good job, Callista. Very good. I like your answer, Jesse. What about the rest of you? What do you guys think? A was t equals 5. What is going to be B for 1 day? Very good. T equals 24. Because there's 24 hours in 1 day. Okay, and what about 1 week? Remember, it's hours. We're being asked hours. So in 1 week, how many hours are there? 1 day is 24 hours. What's 24 hours times 7? That is correct. 168. Now, did this problem tell us how many times it's compounding? No. So if we see that it doesn't give us a compounding, we just assume it's 1. Okay? So now we're going to plug in for each one. So A, we're going to see P, which is 10, 1, plus the rate to the T, which is 5. So we have 10 times 1.8 to to the 5th power. So we put that in our calculator. And what did you guys get? So I'm going to put for my answer, I'm seeing that this is going to be approximately 189. Now the reason why we're going to say 189 for this one is because they say how many bacteria. So we want to kind of approximate that there will be 189 bacteria. 188.96 is very close to 189. So now we do that for B. Same thing. 1 plus 0.28. And for this one, RT is going to be 24. So we're going to follow that same formula again. And that's going to give us, oof, let me try that again. How many of you guys got a big number? So that would be 1,338,258,845 bacteria. That's a lot of bacteria. And that's pretty much how much it's grown if untreated within 24 hours. What do you think is going to happen if we get to do we even want to see what that number looks like? This one is going to be 7.69 times 10 to the 43rd power, which means there are 43 zeros that are going to keep going forever and ever. That is a lot. So I just wanted to make sure to show you this type of problem because you are going to deal with problems like this as well on your homework and on your test. I am going to give you guys some review work next week, so look out for that. Are there any questions regarding like exponential growth regarding like hours?